Welcome to the Mid-Atlantic Water Program training module on septic system function and maintenance. These partners were involved in developing this module, and the following individuals contributed to this presentation. During this presentation, we will review the components, function, and maintenance of a conventional gravity flow system, as well as introduce some alternative septic systems. Because on-site septic system regulations vary from state to state, we will quickly review the regulations that are common amongst the Mid-Atlantic states. We will also discuss some potential water quality implications associated with using on-site systems, and we will cover basic septic systems do's and don'ts. Finally, we will introduce you to additional on-site septic system educational materials and resources that you may explore if you choose. A typical conventional gravity flow system is comprised of three key components: a septic tank, an effluent distribution system, and a drain field, absorption system, or treatment area. Each of these components plays an important part in treating wastewater from the home. Sewage and gray water, which is used when showering, doing laundry, and other purposes that do not involve the toilet, flows into the septic tank. When functioning properly, solids are captured in the septic tank and digested by anaerobic bacteria, which are bacteria that thrive in the absence of oxygen. As the solids are digested, a layer of sludge accumulates in the bottom of the septic tank. The sludge must periodically be removed by pumping out the tank. The liquid or effluent in the septic tank passes out of the septic tank to the distribution box, where it is evenly distributed to pipes that further distribute the effluent across the soil treatment area. The soil provides a filter medium, and naturally occurring bacteria further treat the effluent. Clean effluent eventually infiltrates, entering the groundwater system. Septic tanks are buried watertight containers located near a dwelling. They can be made of concrete, fiberglass, or polyethylene. Due to durability and lower costs, concrete tanks are the most commonly used in residential on-site systems. Polyethylene tanks are among the least expensive septic tanks, but have issues maintaining structural integrity under the weight of saturated soil. In recent years, advances have been made to the construction and material of polyethylene tanks. With the ribbed design seen in the upper right picture, polyethylene tanks are becoming a more viable solution. A fiberglass tank is another alternative. Fiberglass tanks are more expensive than small concrete tanks and are often used in larger on-site septic systems that may serve multiple houses or commercial development. This is an illustration of a typical two-compartment septic tank. The septic tank provides primary treatment of wastewater from the home. Wastewater from the house enters the tank from the left, called the inlet. Solids settle to the bottom of the tank while scum, oils, and grease float to the surface. As solids are digested by bacteria in the septic tank, sludge, it accumulates in the bottom of the tank. As the effluent, or the liquid in the tank, accumulates, it flows into the right compartment, where additional sludge and bacterial solids settle out. The effluent exits the tank through the T outlet on the right, and in a conventional septic system flows by gravity to the distribution box and to the soil treatment area. Periodically, typically every 3 to 5 years, the septic tank must be pumped out to remove the accumulated sludge and scum to prevent clogging the soil treatment area. The distribution box receives the septic tank effluent and distributes it evenly to pipes buried in the soil treatment area. These pipes are typically called laterals. The effluent exits the laterals and slowly infiltrates into the surrounding soil. The soil in and below the soil treatment area physically filters the effluent, and naturally occurring soil bacteria further treats it. The photo on the left illustrates the distribution box. The single hole in the side of the box is the inlet to the box from the septic tank, and the holes on the 3 other sides are where the soil treatment area laterals are connected to the distribution box. The photo on the right shows the concrete distribution box in the foreground and 2 distribution laterals being buried. The 2 laterals are laid in a bed of gravel to promote effluent flow into the soil treatment area. A conventional gravity flow septic system uses a number of distribution laterals to deliver the septic effluent to the soil treatment area. Laterals are slotted or perforated pipes buried in trenches, typically 1 to 3 feet deep. The lateral is typically laid in a bed of gravel to promote effluent flow to the soil treatment area. Soil conditions dictate the number of laterals and trenches needed to adequately distribute the effluent. Soil texture determines how quickly effluent will be absorbed into the soil. Fine textured soils, such as those containing a lot of clay, don't function well as soil treatment areas. Coarser textured soils, sands and loams, will absorb effluent more readily than finer textured soils. The suitability of a potential soil treatment area site is assessed by performing what's called a percolation or perk test. This measures how quickly water percolates and moves through the soil. Soils with more rapid percolation rates are better suited for conventional gravity flow septic systems. Soils with slow percolation rates that have layers that limit subsurface water movement or are underlain by shallow groundwater will likely require some kind of alternative septic system, which we'll discuss later in this presentation. This slide shows a schematic of the conventional gravity flow septic system lateral on the left. In this illustration, the distribution lateral is laid in a bed of gravel. The top of the gravel is covered by a geotextile fabric to prevent soil intrusion into the gravel bed from above. Traditional soil treatment area designs are popular because of their low cost and simple design. An alternative to the typical gravel-filled trench installation is the use of engineered infiltration chambers, shown here on the right. Soil infiltration chamber soil treatment area installations are a viable alternative if the soil in the treatment area is suitable. These arched, high-density plastic chambers are open at the bottom and slatted on the sides. This design allows effluent to infiltrate into the soil directly from the chamber. Gravel is not used in this system. Infiltration chamber systems will work well where a conventional soil treatment area is also an option. Septic systems use natural processes to treat wastewater. This diagram helps explain the processes. Wastewater originates from within the house, from human waste, showers, washing machines, etc. The wastewater flows into the septic tank where pretreatment occurs, and solids settle out in the first chamber of the septic tank, and bacteria that are common in the human gut work to digest and decompose the solids. A byproduct of this digestion or pretreatment process is the sludge. As we've discussed, the sludge settles to the bottom of the first chamber in a typical septic system. The liquid fraction of the waste stream passes into the second chamber of the septic tank, where additional treatment and any additional sludge settling can occur. The relatively clear liquid that eventually exits the septic system is called effluent. Effluent flows through the distribution system, where it is evenly distributed to the soil treatment area. The effluent slowly percolates into the soil in the soil treatment area. The effluent in the soil treatment area may supply water and nutrients to plants growing along the soil treatment area. Various other chemical, physical, and microbial processes act to consume and degrade any remaining contaminants in the effluent. Additionally, the soil acts as a filtering medium. A properly working septic system results in treated, clean effluent seeping into groundwater. Septic systems may fail for a number of reasons. The most common causes for failure are the clogging of the distribution system and disruption of septic system flora, which is the bacteria that populate the system and aid in the treatment process. Over time, sludge builds up in the septic tank, and if left alone, it may move from the tank to the distribution system and clog the system or soil treatment area. To prevent this, one should have their septic system tank pumped every 3 to 5 years. The more people there are in the house, the more frequent you should pump it. In addition, take care to keep grease, oils, and fine particles out of your septic system because they can clog the area as well. If you must use a garbage disposal, do so sparingly. Harsh chemicals, including many household cleaners, can be harmful to the bacteria in a septic system. The bacteria in the system are the engine that drives the treatment. Taking care not to harm these bacteria is critical in maintaining a properly functioning system. Use chemicals for household cleaning sparingly. Look for septic-safe alternatives. Another cause of failure is that related to the soil treatment area clogging. Excess water use in the home. When too much water enters the tank too often, the solids don't have the opportunity to settle out, and the sludge in the tank can be resuspended. To the extent possible, spread out heavy water use over time. For example, avoid doing multiple loads of laundry on any one day. Bad odors are one sign that your septic system may be failing, especially after heavy water usage or rainfall. along with soggy wet soils, wet spots with lush green grass growth over the soil treatment area or septic tank, and standing water in the soil treatment area. These are all possible signs of septic system failure. If you notice that household fixtures are draining slowly or you are experiencing plumbing backups, the cause could also be a septic system failure. When high levels of coliform are found in well water, which is a type of bacteria, the septic system should be inspected to ensure it's not the source of contamination of the well water. To ensure your septic system continues to function properly, follow these good management practices. Practice water conservation through the use of low-flow toilets and shower heads, and match the volume of water used in the washer to the size of the laundry load. Avoid washing more than 2 to 3 loads of laundry per day, and only run the dishwasher when full. Avoid harsh cleaners and use all cleaners sparingly. Harsh chemicals can be harmful to the bacteria in the septic system. Avoid using the garbage disposal. Solids and grease from garbage disposals can clog the soil treatment area. Maintain a healthy grass cover over the soil treatment area. Divert runoff from the soil treatment area by making sure household downspouts point away from the area. This will reduce excess runoff to that area and allow effluent to infiltrate into unsaturated soil. Perhaps most critically is to have your septic tank pumped out regularly, at least every 3 to 5 years. Regular septic system maintenance is needed. This is the only way to ensure proper operation and prevent water supply contamination from effluent. A typical septic system inspection will involve locating the system, uncovering access holes, checking for signs of plumbing backup, measuring sludge and scum levels, identifying leaks, examining mechanical components, and pumping the tank if necessary. A good rule of thumb, as we've mentioned, is to have your tank pumped out every 3 to 5 years. Septic system regulations vary from state to state. Common regulations include a site visit to evaluate the soils and locate and size the soil treatment area. This site typically involves locating property lines and the location of any structures. It also involves testing the soil for its ability to accept the effluent. This is called the perk test. The type of system is often included in the regulation. This is typically a function of the soil and its percolation capacity. Soils with slower or limited percolation capacity may require an alternative type of septic system. Regulations typically also govern the size of the septic tank, which is usually determined by the number of plumbing fixtures or bedrooms in the house. Finally, regulations often dictate the physical location of the septic tank, specifying minimum distances from buildings, wells, and springs, etc. Some states may have additional regulations that govern system type, location, and maintenance depending on the proximity to environmentally sensitive areas. While conventional gravity flow systems have been described in detail, they are not the only type of septic system available. Alternative systems are available for those whose sites are not suitable for conventional systems. These alternative septic systems typically involve pumping the effluent to the soil treatment area in timed cycles, often called dosing. Two common alternative septic systems are the mound and the drip irrigation system. The mound system uses raised soil treatment area consisting of sand fill that allows for additional time and soil volume for infiltration and effluent treatment. For the drip irrigation system, engineered tubing is typically buried 6 to 12 inches below the surface. Drip systems require cleaner effluent to prevent clogging of the drip tube. These systems are typically coupled with an aerobic treatment unit. A pump is used to aerate the material in the septic tank. This promotes the growth of aerobic bacteria, which more completely decompose sewage solids, yielding a more highly treated effluent. Here are a few septic system do's. Do know where your septic system is. Have your septic system inspected periodically and pumped as needed. Keep records of inspections, pumpings, repairs, and permits. Use commercial cleaners and detergents in moderation. Mild detergents or baking soda are preferable. Plant only grass over and near your septic system. Keep water usage to a minimum and divert surface water runoff away from the soil treatment area. Things to avoid when trying to maintain your septic system. Don't treat your septic system like a trash can. Avoid introducing finer floating solids and material that's difficult to digest. Avoid using garbage disposal. Don't drive or park vehicles on any part of your septic system. Doing so can compact the soil treatment area and damage pipes or tank or other septic system components. Don't introduce harsh chemicals into your system, which can kill needed bacteria. Don't flush medicines down the toilet. Effects on human health and the environment are not currently well understood. And don't use septic tank additives. They have not been proven effective. In summary, here are a few key topics that we covered. Conventional gravity flow systems are comprised of a septic tank, distribution box, and soil treatment area. Primary treatment in a septic system occurs in the septic tank where heavier solids sink to the bottom and are degraded by naturally occurring bacteria. The liquid or effluent that exists in the septic tank travels through the distribution box and is dispersed across the soil treatment area where the soil and soil microbes provide additional treatment. It's good practice to have your septic system inspected annually and pumped out at least every 3 to 5 years. If the tank is not checked regularly, the homeowner runs the risks of solids building up in the tank and clogging the treatment area. This can be the leading cause of septic system failure. In some situations, conventional gravity flow septic systems won't work. There are alternative systems available. Each potential septic site and application is unique. By following a few simple suggestions and actively caring for your septic system, this will ensure your system will continue to function properly throughout the design life. Good practices can be as simple as regular inspections, practicing water conservation, limiting the use of harsh chemicals and cleaners, and avoiding compacting the soil above the soil treatment area. Here are some additional resources that may explain and illustrate septic system function and maintenance. And here are some links to the state regulations for each of the Mid-Atlantic states. Here are some common definitions that we've included in this presentation, and their definitions are here. And the sources for the pictures that have been used in this presentation. Thank you for your time and attention. Additional information can be found at these e-extension sites. Please feel free to visit them for more information.